Hey, I've been having seizures and difficulty walking. Well, you might have brain cancer. We should get you an MRI to check that out. Well, what is an MRI? Well, in 1937, Professor Isidore Rabi was working in the Pupin Physics Laboratory in Columbia University in NYC. There he observed nuclear magnetic resonance, NMR. He saw that atomic nuclei will absorb or emit radio waves when exposed to a strong magnetic field. Then the Tesla unit was declared in Munich by the International Electrotechnical Commission Committee of Action, and the Tesla measured electrical field strength. All MRIs are calibrated in Tesla units because the stronger the magnetic field, the stronger the body's atoms release radio signals, and the higher the quality of the MRI. In 1971, Raymond Damadian from Brooklyn's Downstate Medical Center discovered that cancerous tissue and tumors contain more hydrogen than healthy tissue because tumors contain more water. He patents the idea of using the NMR to look for that stuff. Then in 1973, Paul Lauterbur made the first NMR image of a test tube, which took him 5 hours. Finally, in 1977, Damadian makes an MR scan of the whole body. But what is an MRI, and how does it work? MRI stands for Magnetic Resonance Imaging. Its purpose is to use a strong magnetic field and pulses of radio wave energy to create pictures of organs and other structures in the body. Now, normally, your body's atoms spin in their own random direction, like top. When the MRI magnetic field is activated, the hydrogen atoms line up with the field, either north or south. Every atom usually has a pair, so one will go south and one will go north, but there are a couple unmatched atoms. When the MRI sends out a radio pulse, the unmatched atoms spin the other way. When the radio pulse stops, the unmatched atoms spin back to their original direction while emitting energy. The computer takes in that energy and uses math to interpret the signal into an image. Just some basic MRI parts, like the radio frequency coil, which releases the radio pulses, or the magnet, obviously, or the gradient coils, which have electric current running through them, or the patient table. So for the MRI test, you'll have to remove your clothes and any metal on your body because it'll be attracted to the magnet. So for an MRI, they'll put your whole body inside a big tube that contains a huge magnet, and an MRI technologist will perform the MRI and a radiologist will interpret the images created. During the test, you'll lie on your back inside the scanner, and your head, chest, and arms may be strapped to keep you still. A coil might be placed over or wrapped around the area that you need to scan, and you might also have a special strap to detect your heartbeat or breathing to trigger the machine to take the scan at the right time. For people who feel claustrophobic in an MRI, they also make open MRIs that don't surround your whole body with the magnet. However, the images will probably be of lower quality than a standard MRI. Okay, typically MRIs will take 30 to 60 minutes, but some of them can take up to 2 hours. And for reasons not to have an MRI, well, they won't really give one to you if you're pregnant unless you have complications. And if you have any medical devices with electronics or iron in them, they don't give you an MRI because it messes all that up with the magnets and stuff. Also, if you're unable to sit still, or if you're obese, you can't take one.
Bob, I am sorry to say that you have brain cancer.